Good afternoon, everyone. First of all, thanks for the nice introduction, Fernando, and welcome to everyone who's joined us. Today I'm going to speak about Ampashield. As Fernando mentioned, it's nano-carbon enabled coating solutions. Okay. So first we're going to discuss a little bit the history. We're a relatively young company, but we still have a lot of information to give. And then we'll talk about our mission statement, operations today and in the future, service packages that we offer, and products and the features. Okay. So moving on to history, on the screen now, you can see the lifeline of Ampashield. We first met Rubis and two scientists from Cambridge University back in 2012, courtesy of the Ultrawire project. I'd like to point out here that whilst Ultrawire is about nanocarbons embedded in copper, this is nothing to do, our product Ampashield is nothing to do with Ultrawire. Okay, so after the, should we say, the work together during Ultrawire, Kinetics was formed by the two scientists in Cambridge University, and the Rubis started to work together in Kinetics on Ampashield. And then recently, this year, in March 2019, we created Ampashield NV, or limited company, between Rubis and Kinetics. 75% ownership Rubis, 25% ownership Kinetics. So what is our mission? Our mission statement is the following. Ampashield NV wants to be a leading supplier of nano-carbon enabled coating solutions that enhance its customers' product performance. And we will discuss in more detail on the portfolio and how that works for your products in a few slides. So operations today. We have a lab scale coating production in the UK, currently at 3 litres a day. We have plans to scale up to 20 litres a day. To give you an idea, what does 1 litre of our product represent? It would represent, if we talk about copper substrate, this would be 1 litre is enough to cover 2 tons. 2.5 litres would be enough to cover 1 ton of product, depending on the size of the product in the question, should we say, the surface area of the product in question. Oh, sorry, return doesn't work. So then we have plans in our business plan to scale up to larger volumes as and when the industry requires it. It's marked here in Belgium, but this can be anywhere in the world, basically. It will depend on where the end user is. They can even be located in the end application factory. So service packages that we offer today, there are 4 variants: basic, advanced, premium, and platinum. So basically, we just offer the coating itself. Okay. We offer the product coated, so your end article coated, and then we offer a consultancy service based on what you require, your specification. We can lead you to the correct, shall we say, formula. And then we offer a platinum service as well, where we give you consultancy on application and machinery as well to apply the product. So down to the technical details now, just a brief overview of the products in question. We have Ampashield Thermal, Ampashield Protect, Ampashield Plus, and Ampashield Flex. They are all based on nano-carbon technology, and they all offer various, should we say, properties. Okay. And we'll discuss more in detail on the next slide. We'll go into more detail on each of these products. So that's 4 products today that we have in our portfolio that we offer on the market. Okay. So product features overview. Here we see a chart giving you the, should we say, a representation of the 4 products and how they compare to each other. 5 being the best performance, and 0 basically it does not, it lacks that property. So for example, if we take Ampashield Thermal, top left-hand corner, we see increased ampacity is 5. You'll see some lab results from big site testing on that in a minute. You'll see it's not conductive electrically at all. Okay, so it's considered an insulator. For example, all 4 of them are showing excellent heat resistance to flame. Okay. Ease of application, you can see from the second column to the end. Thermal and Plus can either be sprayed or dip coated. Protect and Flex can be sprayed and dip coated as well, but we need a further cure. Okay, should we say a further heat treatment afterwards. So that chart just gives you a representation of the 4 products today. Moving on. Over to the film, please. So you'll see here the application of the Ampashield Thermal on a copper buzz bar in our laboratory in Cambridge. You see it's very much akin to a very light coat. Okay, I'll play that again for you in case you missed it. It's very easy to apply. You degrease the product, clean it of debris, degrease, apply. It's touch dry in a matter of seconds. Should we say 10 to 15 seconds? It's touch dry. You can place it back into the box. Okay, back to the presentation, please. So we see there on the right-hand side, we see some samples of buzz bars coated that were tested in, should we say, in the field. Moving on to the next slide. Ampacity increase. So we see on the screen now a chart representing a copper conductor. 22 by 0.7 is the size. It's a very small copper strip. We see the orange line and we see the blue line. Okay, so this is the ampacity of copper at 80 degrees C. Okay, and we see an increase in ampacity at 32%. Okay, so obviously the blue line is representing the copper coated with Ampashield Thermal. Now, if we move on to the right-hand side, we again increase the temperature of the same strip to 200 degrees, and we see an increase of 41%. Okay, from bare copper to coated copper with Ampashield Thermal. Why is that so? There are 2 factors involved here. Emissivity. Okay, if we take emissivity of copper, of hard drawn copper or half hard drawn copper, 0.1. Oxidized copper, which what you might expect in your switchgear after a few months to a year, is 0.4. Black paint, for example, is at 0.9. Ampashield Thermal is at 0.99. So this is why you see this improved, enhanced performance of the ampacity. Now, it's a combination of not just the radiation effects from the emissivity, it's also the superior thermal conductivity of the base product itself. Okay, so the carbon, the nano-carbon. If we take measured values today, we have 1.3 watts per meter per Kelvin. We have an emissivity value of 0.99, and it's a combination of both of them that gives us a superior performance over any other coating on the market. If you're wondering, ampacity is defined as the maximum current in amperes a conductor can carry continuously under conditions of use without exceeding its temperature rating, also described as current carrying capacity. Okay, so moving on. So here we're going to demonstrate, over to the video, thank you. Here we're going to demonstrate the impact resistance. We see the product being bent there. Again, this is a 22 by 0.7 strip. We see the cross-cut test complying to ISO 2409. We see the cutting resistance here is excellent. And we see all of them demonstrating excellent adhesion. I just play the video again, so I think we missed the first part. Impact resistance. So we see the impact resistance there complying to 6272 is a 1 kilogram mass. The bending resistance is complying to ISO 1519, part 1, cross-cut test, as I mentioned before, and the cutting resistance. And you can see in all of them the adhesion is excellent to the substrate, no matter whether it's copper, aluminium, steel, albeit. Okay, back to the presentation, please.
Actually, we can play the next video, Peter.
Oh, sorry, Fernando.
There are 4 in a row.
Okay.
You can go ahead.
Yeah. So we see here the resistance to acetone, MEK, toluene, more commonly known as paint thinner, surface coatings, and used for surface coating and adhesives, nail polish remover, sometimes used in. And you see there classic metal paint just basically bubbling up and removing itself from the substrate. Okay, just a quick play again for everyone. So we did the experiment for 3 hours, and you see the coating was very resistant, no effect. And as with normal coating, this came off. Okay, now we go on to the next video. Okay, so we see here flame resistance. So we've got a 22 by 0.7 strip again, coated in Ampashield thermal. We're still on thermal, by the way. And we see there the copper is glowing, should we say orange, dull orange, which means we're in the region of 500 to 600 degrees centigrade. The product is resisting, the coating is resisting the temperature. As I play the next one, we have a normal coating on there. I have to pause that one. That's right. Fernando, could you please take the second video?
Yes, let me try at my end.
So we got a standard coating exposed to heat here. And you see very quickly in a matter of seconds, 5 to 6 seconds, it's burning and disintegrating. For your information, we recommend this. We recommend use of Ampashield thermal up to 250 degrees centigrade. 250 degrees centigrade continuous use. Okay, on to the next part. Okay, so videos, still shots. So coverage capacity. I mentioned coverage capacity earlier, equating to tons of copper. In here we say 1 litre of Ampashield thermal is sufficient to coat up to 10 square meters. That's at a thickness of 10 microns. You only need effectively 5 to 7 microns for the product to be effective, to carry all of its performance. If you just apply it any thicker, it makes no difference to the performance properties. What we can do, we can apply multiple layers, an alternative top coat, which is an alternative lacquer that can provide dielectric strength as well. And this is providing dielectric strength, so we say, is 40 kilovolts per millimeter. Okay. On to the next one. Video, please. So we see here, we don't see anything yet. Okay, so we see a woven glass fiber composite. So we're saying it's conductive medium flexible heaters. Okay. And you see it's very flexible. We've just taken this woven glass fiber and just dipped it in Ampashield Plus now, sorry, we're on to Ampashield Plus. And we see on the screen now, we're heating up the should we say, the blanket. I'm going to play that again. Okay. You see we're heating up, okay, to 170 degrees. We applied a current to it, obviously in voltage. We're heating up to 170 degrees in a matter of seconds, 22 seconds, and we're cooling down very quickly as well. So it's losing its heat very quickly as well, so it's very efficient. We say the sheet resistance is 50 ohms square at 10 microns. We use for shielding, signal transmission, for example, resistive heating, as we've just shown there. On to the next video. I think you might have to play the next video, Fernando.
Yes. Let me try it.
So what we have here is an aramid woven wire coated in Ampashield Plus. Okay. You can see it's very flexible, retains its form. We pull it out again. So also, for example, there, shielding, signal transmission. It could be used for high voltage ignition cables, for example. Okay. So pass back to the presentation now, please. Okay, there's the still shot. Just for your information, just to show you that Ampashield Plus, you see on the right-hand side of the screen there, a wooden block coated with Ampashield Plus, and we applied about a power source, and we see we're lighting up a little LED there. Okay, to show that it's conductive. Okay. Okay, still shot. Now we move on to Ampashield Protect. Okay. Now you see on the screen there some carbon steel. There's two pieces of carbon steel, basic carbon steel. Both were submitted to, one is bare carbon steel, one is carbon steel coated with Ampashield Protect. They're both immersed in sulfuric acid, a 10% concentration at 65 degrees centigrade for 48 hours, which is basically the evaporation time. You can see on the right-hand side, complete disintegration. On the left-hand side, no effect. Why do we do it? 10% concentration of sulfuric acid, 65 degrees. It was considered a possibility, still is considered a possibility for, should we say, electrolysis. Okay. So moving on, you can see also, whilst it's Ampashield Protect, and if we were to go back to the chart, and you can use that as a reference later, you can see that the Protect is still given a 28% increase in ampacity, whereas the thermal would give you a 32% increase in ampacity. Okay, so that was quick. Now, onto the film. What we have here is Ampashield Flex. I think you're going to have to play the video. I'm struggling with the play.
Okay, I will play it again.
Okay, so on the top screen there, you don't see it so well. Right, yeah, you see the wire. What you've got there, you have enameled wire, coated, it's 100 microns diameter. It's coated with 8 microns thick Terabec, so a standard enamel coated, and it's submitted to a current, and it's going up to 80 degrees, I think. Very disconcerting, only seeing the video and not the presentation. And we see that it fails after a matter of 3 to 4 seconds. If we play the next video, please, Fernando. This is a 100 micron wire again, coated in Ampashield Flex, okay, and submitted to the same conditions, okay. And we can see here that it's just started playing now. So it's, as I mentioned, it's 100 micron wire, coated in Ampashield Flex, same thickness as the TerraVec coating in the previous video, and we will see that it fails at 44 seconds. I'm afraid we've got a few seconds to go here. This is applied much the same way as a enamel coating. And there we see failure. So we see that it lasts approximately 15 times longer than the enamel coating in the previous. Okay. Okay, back to the presentation, please. So what we can say about the enamel versus the flex enamel is that the TerraVec, in this case, uses MT533-37. There's a thermal conductivity in the region of 0.25 to 0.3 watts per meter per Kelvin. The flex, in this case, has a thermal conductivity of 1 watt per meter per Kelvin. So you can see the potential of thermal dissipation here as opposed to the enamel. So combining enamel properties with nano-carbon results in a coating with good dielectric strength. It's flexible and temperature resistance is very high. It's a point to note here, the 250 degrees centigrade that I mentioned earlier does not apply to flex and be in the region of 200 degrees, 210, okay? Moving on. So we look here at possible future applications, and these future applications are being explored as we speak. So we see in the center, we see some aluminium coated sheet around the edges. This is the Ampashield Protect, and like I mentioned earlier, this could be considered in tank houses for anodes. Okay. We go down to the bottom right with the photovoltaic cells. So here we can use Ampashield thermal on the backside to have a good radiation effect to remove the thermal heat. And also you could use the Ampashield thermal in another form as a dispersion as the cooling medium. Due to its high thermal conductivity, this would be far superior to the cooling mediums that are in there today. We're moving on to radiators. So there's a classic radiator there shown. Again, that's just for Ampashield thermal emissivity. One that might not be so apparent. So in the top right-hand view, we see an oil pipeline. So one of the major problems with oil pipelines is the buildup of sludge, slime, residue on the inside, so restricting the flow rate of the oil. If we apply Ampashield Plus to the inner liner, apply a small current, this will eliminate the buildup of residue on the inside of the pipeline, and it's eliminating the need for regular maintenance and cleaning. We've seen the resistive heating sheet on the left-hand side. We see some cables here, which were coated in Ampashield thermal. So this enabled one producer to reduce the wire size by 1 grade, hence saving an enormous amount of, shall we say, kilograms in the aircraft, hence basically giving them a longer distance he could fly for the same amount of fuel. And we discussed Ampashield Flex earlier in the motor, in the windings. So that's what we see today as some possible future applications, apart from the others we mentioned. Okay. So I thank you for your time, and I open the